Okay, this is the P1 paper from October 2024. It's question number 2, and as you can see, this is a question on algebraic expressions. We're going to be looking at some index laws, and then we're going to be working with surds, and almost certainly at the end, rationalising the denominator. Let's have a look at the first part then, part 1. It says simplify fully, and what have we got? We've got 3y cubed, 2x to the power of 4 all cubed, all divided by, and then we've got 4x squared y to the power of 4. So let's just sort out that bracket with the cubed. Leave 3y cubed alone, but then 2x to the 4 cubed, or 2 cubed is 8, and x to the 4 cubed like that, we know the index powers, multiply the powers together, gives me 8x squared. Same denominator, all divided by 4x squared y to the 4. And then it's just how many steps you want to do here. I'll do one more. So I'll say that's 24 with the numbers. I've got x to the 12 y cubed, all divided by, I've not done anything with the bottom, 4x squared y to the 4. And then 24 divided by 4 is 6. X to the 12 divided by x squared is x to the 10. And we've got y cubed over y to the 4. They haven't asked me to write it in any particular way, so that seems to be the simplest way that I'm going to do that part 1. So simplify that fully. We've done that. Now the next part says find the exact value of a such that this is true, but then it does tell me here that it wants the answer as p root 3. So if I'm looking at the question, you might do this later on in your working, but I'm actually going to get rid of root 27 straight away. Root 27 would be the same as root 9 times 3, which is root 9 root 3, which is 3 root 3. Now you could do that straight away on the calculator anyway, but just quick little bit of revision there for that bit. So let's get started with the question. So what have we got? It says part 2. We had that 16 over root 3 plus 1 is equal to, I'll leave it as it was to start off with, a root 27 plus 4. So what I've now said is that root 27 is 3 root 3. So I've got a 3 root 3 plus 4 is equal to 16 over root 3 plus 1. So I want to try and make a the subject of this. There's lots of different ways of doing it. What I'm going to do is I'm going to get rid of that fraction first of all. So I'm just going to say a 3 root 3 plus 4 all multiplied by root 3 plus 1. Different ways of doing this, but yeah, it seems like a sensible way to go. 16 is equal to, multiply out these two brackets, so you can take your time over doing this. But a 3 root 3 all times root 3 and a 3 root 3 times 1 and then 4 times root, you know how to multiply out two brackets. I'll tell you what I got it to be. 9a for the first part, 4 root 3 and then a 3 root 3 and then plus 4. I know you'd say 3a root 3, but just try and keep it all as simple as possible. And then if I want to get a equals, what I'm going to do is to say this is 16 minus 4 root 3 minus 4 is equal to 9a plus 3 root 3a. And I'm going to take a as a factor there, which will give me 9 plus 3 root 3 here is equal to, and that's 12 minus 4 root 3 now, isn't it? And so I'm going to get that a works out to be equal to 12 minus 4 root 3 all over 9 plus 3 root 3. There are very many other ways of doing this, as long as you get the same answer with me at the end. If you've done this in a slightly different way, that's absolutely fine. No problem at all here. What I'm going to be doing then is now rationalising this denominator on the bottom. So I need to times by 9 minus 3 root 3 here, which means I'm going to times top and bottom by 9 minus 3 root 3. So if I do that then, this times this, this times this, this times this, and this times this, We'll do all that in a second. But the bottom, the denominator at least, when I'm doing that bit, I'm going to get 9 times 9, which is 81, minus these two times together. I don't need to worry about everything else because the whole idea about rationalising is that that works out. 9 times 9 is that. 3 root 3 times 3 root 3 works out to be 27. So I'm getting 81 minus 27 on the bottom. On the top, multiplying it all out, again, I'll just show you what I got. I've already done it. 108. I get minus 36 root 3 minus another 36 root 3 and then plus 36. What does this all tidy up to? It tidies up to 144, 72 root 3 all over 54, and then things can cancel there. So if we tidy that up to make it, what did we want it to look like? They asked us to have it looking like a multiple of root 3 and then q, and it says p and q are going to be fully simplified rational constants, so in other words simplified fractions. So here I'm going to get 8 over 3 for 144 over 54, and then 72 over 54 is 4 over 3 root 3. So I've now got that in the format I wanted. As I say, there were lots of different ways of doing that. You didn't need to do that at the start. Here you could have minused 4 and then divided by 3 root 3. It doesn't matter which way around you want to actually do it. My way works relatively neatly, so I'm quite happy with that. As long as you get the same answer as me at the end. If you did it a slightly different way, think about how long it took you. Okay, hopefully that makes sense to everybody.